Hello and welcome back to my favorite people, and thank you very much for watching this lecture video. And I'm going to start the lecture with treating an ether with acid, and after that one, we're going to switch to epoxide. And we know ethers are sensitive to acidic condition because there is oxygen there with two lone pair, and it can abstract a proton. So first step of this reaction is going to be this oxygen. It will go to after acidic hydrogen, and it will take that hydrogen and that proton technically from the HBr, and here we have a positive charge, partial positive charge on hydrogen. So the intermediate we will get, it will be something like this. The first one lone pair, it will be gone. So let's erase that lone pair and replace it by a hydrogen atom. And here you go, a hydrogen atom. Now we have a positive charge on oxygen, and oxygen is not going to be happy. That means this intermediate is capable of actually getting involved in some chemical reactions. Next step of this reaction, we will have a nucleophile. And nucleophile, it can attack the carbon. Why carbon? Because that carbon is attached to oxygen, that it has a positive charge, and oxygen is going to pull good electron density from that carbon, and it will create a positive charge on carbon. And this is going to be a SN2 reaction. On the nucleophile, it will be the bromide. Okay, so next step of the reaction, our intermediate, it will be attacked by the bromide or the nucleophile, and it will kick oxygen out of the system, but oxygen, when it's leaving, is leaving as OH. So now the formal charge on it will be 0, and we call this one phenol. And other side, we will have a bromide replacing oxygen, and that's going to be alkyl halide. Okay, you might say, why don't you attack, let's say, this carbon? Why the nucleophile is not attacking that one? Why just is going only after carbon, the one on the right side, and not that carbon? That's not going to happen. The reason for it, this carbon, forgive me, this carbon, it has sp2 hybridization. So that means that the interaction between carbon and oxygen, this interaction is going to be really strong interaction versus the carbon that we have here. This carbon, it has sp3 hybridization. That means the interaction between carbon and oxygen is weaker than sp2 carbon. So the weaker bond, it will be the one I'm going to highlight. This is going to be the weaker bond, and breaking that bond is easier than breaking oxygen carbon bond with sp2 hybridization. Okay, so now that we know like we cannot actually replace the OH and phenol by bromide, the reaction is going to stop here, and it is not going to go further. It doesn't matter how much acid we have actually inside the solution. You need to technically run other chemical reaction to replace OH by something else. Now I'm going to switch to epoxide. And epoxide, still we're talking about ether, but our oxygen this time is involved in a ring. Technically, it's forming a ring instead of just a linear molecule, and that's the reason we call it epoxide. And the ring, it can be made of 3 members, 4, and go up. And each one, it has a common name. The most common one that we use it in a lot is going to be the oxyrane. Oxyrane, it has 3 members. And I'm going to try to name the epoxide based on this, 3-member ring. Okay, we have 2 methods to name any epoxide. The first method, just simply use epoxide. Use epoxide to name the compound, and the second one, we're going to use oxyrane and to name the compound. Let's practice those 2. So we will be using epoxide and oxyrane to name the compounds. Okay, so if our ring is made of just 3 atoms, and one of them is oxygen atom, we can call it oxyrane. And the labeling always is going to start from an oxygen. Oxygen will be number 1, and then we say 2, 3. Okay, so oxyrane is an epoxide that it has 3 members, 2 of them carbon and 1 oxygen. Remember this, that we do have hydrogen atoms here. Those are hydrogen atoms. 2 of them are back, and 2 of them are facing to us. Okay, another way to name it, you can treat it as alkene, and then say oxide. Why alkene? Because in fact, it's an ethylene molecule that oxygen was added to it. And we got this. We got something like this one. Now I'm going to put oxygen somewhere here, and those are hydrogen's atom. So another way to name it, and we're going to call it ethylene oxide, okay, instead of oxyrane. Or we can say, you know what, like the biggest change is this one, and it has 2 carbon. And the first and second one, we have epoxide or oxygen. So I say 1 and 2, I go on 1 and 2, I have epoxy. and then I say ethane. Okay, so we use the epoxy before the alkane, and while when it comes to oxirane, it will be at the end of the name. And I'm going to practice a good number of questions, and you will see how we're going to use those two terms. Okay, on the left side, I highlighted the ring, and I'm going to start from labeling from here, 1, 2, and 3. And the second carbon, I have methyl, so I'm going to say 2-methyl. Okay, I have substituent, that's a methyl, and this is my substituent, and it's sitting on oxirane. So I go 2-methyl oxirane. Okay, that's one way to name it. Another way to name it is just simply say, like I'm going to start from the left. I say 1, 2, 3. Why from the left? Because you're supposed to give the oxygen, the epoxide, the smallest possible number, and the longest chain here, it has 3 carbons. If we start from the left and from the right, we get 1 and 2. And well, if I start from here, okay, if I start from here, I go 1 and 2, I get only 2 carbons instead of 3 carbons, so my chain is going to be shorter. Okay, and I know I have 3 carbons. Okay, so I'm going to say on the first and the second one, I have epoxy. Okay, epoxy, and then I have 3 carbon. I'm going to call it a propane. Okay, so as you see, the epoxy comes before the alkane. Okay, and like if you have other substituent, then you have to alphabetize them based on the starting letter, and try to order those substituents. Okay, in this case, again, I have a molecule that it has 2 substituent, and on the left side I highlighted the ring, so I'm going to call this one oxirane. Okay, and what do I have there? I have 1, 2, 3. Okay. And why I started it from the left side instead of the right side? Because on the second carbon, I have 2 methyls. Well, if I started from the right side, I don't have any substituent. So then and I will get a 3 and 3 for the substituent. So it's better to label it from the right to the left side. Okay, I have 2. Okay, 2. This substituent is a propyl. So I'm going to say 2 propyl. And next one, I have 2 methyl. Next, I go oxirane. Well, here, if we want to label this one, the longest chain, it will be this one. Okay, and why did I decide to go after this and not this one? Okay, not this one, because I want to include the oxygen also. I need to include the epoxide in my longest chain. So I go 1, 2, 3, 4, 5. Okay, what do we have? We have 2 substituents. One substituent, it will be the methyl, and the second substituent, it will be the epoxide. So I'm going to say I have epoxy versus methyl. The epoxy will get a priority over the methyl, so the correct name for it will be this. On 1 and 2, I have epoxy, and then on the second one, I have methyl, and I have 5 carbons, so this one, it will be pentane. Okay, very good. Okay, next one, we have we have a molecule that I copy paste this molecule, and I'm going to name it through 2 different ways. One through oxirane, and second epoxide. I have 2 ethyls on the left side and 2 methyls on the right side. So I'm going to say this is going to be a 2 and 2 diethyl, and then 3 and 3 dimethyl. Then we say oxirane. Okay, next one, we're going to say this is the longest chain. Okay. And again, we decided to label it from the right side. Why? Because the epoxide will get the smallest possible number. And also we get 2 and 3 instead of getting 3 and 4. Okay. And so the correct name for it, I'm going to say I have 3 substituent, 1, 2, and that's going to be the third substituent. Ethyl, epoxy, and methyl. And let's see which one is going to be the first one. So the epoxy, we have ethyl. Hold on. We have ethyl. Let's write them. Ethyl, and then epoxy, and then methyl. So we should go with epoxy instead of ethyl. So I'm going to say on 2 and 3, I have epoxy, and then I have ethyl. Where on the third carbon? The third carbon, I have ethyl, and on the second carbon, I have methyl, and we have 5 carbons. So this one, it will be pentane. Okay, pentane, and that's going to be the correct name for it. another one. Okay, forgive me. Forgot to erase this one. Okay, how do I name this compound? Okay, this compound. Okay, we have and again we have oxyrain, and we can use the oxyrain to name it. And so we can say we have 1, 2, 3. So I can say, and on 2 and 3 I have dimethyl. Then I say oxyrain. Okay, now I want to say those methyls are in the cis position. So how about this? Cis 2 and 3 dimethyl oxyrain. Okay, or I can say I have cis. Then how about this? Let's get rid of those numbers. Okay, so we're going to say this is going to be number 1, and that's going to be number 4. And in that case, I have 2 and 3 epoxy. And then this one will be butane. Okay, that's another way to name it. Or you can, instead of saying cis and cis, you can say this. Okay, let's say you decided to copy paste one of this. It doesn't matter really which one. So say, okay, decided to copy paste this one. And instead of cis, I'm going to go after the configuration. And I'm going to say this one, it will be number 1. That's number, okay, forgive me. This one is number 1. This is number 2. And that one is number 3. That's number 4. So this is going to be clockwise. We will get R here. And if we go with here 1, this is going to be 2, and this one 3. This one will be counterclockwise. Hydrogen is at the back, so nothing. We don't need to do anything, and that's going to be S. So I got S here. So how about this? Okay, 1, 2, and 3. Okay, on 2 we got R, and on 3 we got S. So the correct name, it will be 2R, 3S, and you can use the same logic. Okay, same logic for the next molecule. Okay, but this time, instead of cis, say trans. And okay, now I changed this one position of the methyl. So I go 1, 2, and this one it will be 3. Now, if we look to the priority, this is going to be number 1, that's going to be number 2, and this one will be number 3, and that's number 4. So if I follow the number, it's supposed to be clockwise. Hydrogen is facing to us, so this one it will be S. So we get 2S, 3S. Now the question, what's the relationship between these two? They are cis and trans. So this one is a trans, and that one is a cis. So those two, they should be diastereomers. Okay. And next lecture, I'm going to practice more about naming epoxide. But for now, I'm going to stop the lecture here. And thank you very much.